Okay. Maps to matrices. Okay, so let's say you're given a map. We have two vector spaces. What two do you want me to use?
Anything. I just
Okay, well, let's do something simple. Let's do first. Let's do one. Say f from x y to x plus y, x plus y plus z, and z. Okay, so here's a general formula, right? And we want to find the matrix. We want to find the matrix capital F that is represents this. And to do that, we need a basis. So let's say that we use the standard basis for both. Okay, if we use the standard basis for both, then what we do is you look, the matrix is defined by looking for the basis action. So you want to find the first vector of the standard basis and the second vector of the standard basis and find their images using the map F. Well, this is going to be 1, 1, which doesn't make any sense. There's no Z here. So let's do an actual map that makes sense. X minus Y and say 2X. Okay? So then the image would be 1, 1, and 2, and the following one would be what would be 1, minus 1, and 0, right? So therefore, F would just equal 1, 1, 2, 1, minus 1, 0.
X minus Y would be 0.
0 minus.
So it's X plus, so let me see. So if the first one is just X is 1 and Y is 0, so that's 1, 1, 2. The second one, Y is 1, so and X is 0, so it'll be 1, minus 1, 0. Okay, but that's sort of the, let's repeat the same map. X, Y, 2, X plus Y, X minus Y, 2X, and say, let's do the worst case scenario in which we have an unusual basis here, 1, minus 1, 1, 1, and we have an unusual basis here, 1, 1, 1, 1, 1, 0, and 1, 0, 0. Okay? So it's defined the same way in which we take, you need to find the images of the basis B vectors. Using the map F. Okay, so this is going to go to 1 minus 1 is 0. 1 minus a minus 1 is 2 and 2, I think, right? Because X is, this is 2X, this is X minus 1, X plus 1, okay? Then I have to find this other one, so I may as well do, which would be 1, 0, no, it would be 2, 0, 2, right? But the problem is, I'm sort of given the map implicitly in the standard basis. So although I've accounted for B here, this is the right vector here to use. I've got the images in basis E. I have the image of the basis B vector in basis E, so I need to translate that to this other one, and I can do it as a naive way of 1, 1, 1 B 1, 1, 0 plus C 1, 0, 0. which is it's a change of basis kind of thing in which we're essentially saying we want to find a reference to the same matrix. So it's like underneath here is this other technology of identity matrices, but I think the best way to think of it is this naive way that we did it initially. So we have this linear system to solve here, in which I need another. Right, so if I solve this linear system, it's basically, this is the vector form of a linear system whose augmented matrix is 1, 1, 1, 1, 1, 0, 1, 0, 0, 0, 2, 2. And I'm looking to solve for A, B, and C. So, because if I write this out, that's what happens, this form will produce, right? And so then I have to go through and solve this linear system and find A, B, and C, right? So then I would go and do the same thing. So we don't have enough time, it's 1250. I do the same thing for this one. I'd write this one as like R times 1, 1, 1 plus S times 1, 1, 0 plus T times 1, 0, 0. Now let's say I found A, B, and C. What this would become would be A, B, C in basis D. And this would become RST in basis D. So the components of the expansion are then my matrix F in BD would be A, B, C, R, S, T. And it would be from B to D. So I'd have to put in a matrix, I have to put in a vector in basis B, multiply this, and I get out a vector in basis D. So that's sort of the worst case scenario for this, right? So the part I left out was just the linear system part of finding the A, B, and C and R, S, and T. If you have a map G from say A plus BX to say A plus B, A minus B, like that, you do the same thing. If you're finding, you have to have a basis here, say 1x or 1 plus x, 1 minus x. You're given a basis for this space, which is P1. And over here, this is R2. So if we have standard, we could have a standard basis or a non-standard basis for either one of these. We could have 1, 0, 0, 1. We'd have 1, 1, 1 minus 1, a non-standard basis. So we can have so we can do the same thing here. And the crucial point is that each of the vectors here has a representation as a column vector. This is the representation in the standard basis, but it's going to have a different representation in this basis. So if I wanted to know what's the representation of this vector in this basis, I'd say that's equal to P times 1 plus X plus Q times 1 minus X, right? Then the final answer is going to be PQ in basis B. And if I was to solve for this, this would equal, I have to collect terms P plus Q plus P minus Q times X, I think. Because I multiplied out the constant terms and the coefficients of X. Now, if you look at this system here, these polynomials have to be the same polynomial, which means that A has to equal P plus Q, and B has to equal P minus Q, and that's a linear system. And that's where so then you can solve this for solve for P and Q in terms of A and B. So if you're given, like if this was like 3, 4, right? This is a linear, if this as a linear system is augmented matrix, is going to be PQ, P minus Q, A, B. So you're given A and B, and you solve this for P and Q in terms of A and B, and then the result you get is this PQ here, and these aren't necessarily the same. So you can get different column vector, to be a representation means a column vector representation. The crucial thing is you always expand on basis vectors, like this, no matter what the space is. So the whole point of this is the concepts are independent of the realization of what's going on. Okay, so that was like a whirlwind tour of maps to matrices. And you have, so you could have like matrix to maps where you're given the matrix, and you find the map just by acting on the vectors in a given basis and finding sort of what the
I have a question about something just really quickly, some
Okay.
problems on the demonstration. Is it, I know that the format you can do is kind of like, okay, we have one attempt and then we solve it if we get it wrong and we get it wrong.
right.
I noticed that like there were some problems in past demonstrations where like some had 2 attempts and some had 1 attempt. Is that gonna be like the same thing, just to your discretion or?
Well, usually the more than one attempts were on demonstrations were because there were formatting problems.
Yeah.
You know, and there were sort of like, so so sometimes the issue is if you have a question about the format of an answer, you can send me a message, and I'll try, and if I get back in time, that'll help you to know what the format is. But I think that yeah, so the one attempt is to get you to sort of be sure of the answer before you make the attempt. And I know that's a little bit more nerve-wracking, you know, because and especially if you find out the answer right away, it can be discouraging or encouraging, or at least it's entertaining, hopefully. So anyway, so yeah, so this won't be the last time. I mean, it's time to go. Okay, sorry for the since